Hello and welcome everybody. We're going to discuss a certain type of bonds, which are sigma bond and pi bond. We just noticed that the atoms in the universe make bonds to become happy. Okay, so we're going to start like the way of being happy, and we will start with the first one, which is the sigma bond in this case. So generally speaking, sigma bond is in overlapping between orbital. But the way of overlapping here is called end-on. So what is the meaning of end-on? Generally speaking, the end-on results, like if you have an orbital and you have another orbital, they will start to combine to each other in a way of like head-to-head. Okay, so this is the ideal general case. If I want to describe, or let's say to draw the orbital of sigma bond and molecules, how can I do that? We're going to start with the first example, which is the simplest one in hydrogen molecule. You just remember that hydrogen has only one electron and its electronic configuration is 1s1. And the same thing here is 1s1. And we just remember something, that the S subshell has a spherical shape. So this is for hydrogen number 1 and this is for hydrogen number 2. So the two subshells in this case are overlapping with each other, and the sigma bond in this case will be established in form of this. Yeah, so this is the orbital of sigma bond, which is in here. All right. But sigma bond does not have the only shape of orbitals like this. We have different shapes of orbitals, and it depends on the last shell electrons. What do you mean by this? Let's go to the second example. And as we can see here, we have carbon. And you just notice that carbon contains 6 electrons. If we want to write the electronic configurations, it becomes 1s2, 2s2, 2p2. And you notice that hydrogen is 1s1. So we're going to have overlapping between the 1s1, which is, like it's the first shell and the last shell at the same time, and the 2p in this case. We have overlapping between the last shell in carbon, which is p orbital. And the question is, what is the shape of p orbital? So the subshell of p has a shape of this. But since we have p, x, y, and z, then you probably have something like this, which is on the y-axis, x-axis, and z-axis. So these are the orbitals, but we don't have these stuff in this case. Since we say that it's end-on overlapping, then we're supposed to have something, the orbital in this way, which is for p in carbon, and we have another spherical shape subshell of s. Okay, there's no need to write it like this. So they start to overlap with each other. In this case, the result will be in this form. So this is the sigma bond between carbon and hydrogen. And now let's go to the most interesting part in this case, which is if you have a sigma bond that is between the two carbon atoms, in this case, how can I represent the orbitals of sigma bond? Again, we have the electronic configuration of carbon, which contains 6 electrons, 1s2, 2s2, 2p2, and the same thing for the same carbon. In other words, we can say that the overlapping between the two carbons will be between the p orbitals of these. But since we're talking about end-on overlapping, we're supposed to have 2p orbitals in this form. Okay, so they start to overlap with each other like head-to-head. But don't use head-to-head, use this word. It's way better, it's more fancy. So as a result of this, they will have something like this. Okay, so this is the sigma bond between the two overlapping between orbitals like p overlapping. This is end-on. So the sigma bond orbital in this case looks like this, and this is the bond between the two carbons. And now, guys, we studied the end-on overlapping between orbitals, and now we're going to start with a new type of overlapping, which is called sideways. Sideways indicates that they're not end-on, like they start to overlap like side to side. And as a result of this sideways overlapping, we're going to have a bond that is called pi bond. And it appears as a double bond in here. So once you find any compound that contains double bond, put in your mind there is a pi bond in this case. So what are the reasons, or let's see, how did this type of bonding happen? Let's revise and recall something about the carbon. As we told you before, it contains p orbitals in the last shell. And we remember that the p orbitals have a shape like this, right? But since the overlapping is sideways, we're supposed to have a vertical p orbital, and we have another p orbital. This is for carbon 1 and this is for carbon 2. This is 1 and 2, right? So once they start to overlap with each other in a side way, they do not interact end on, just like sideways. They will form an orbital that looks like this. You will have a cloud above the level and below the level. So this is the way of formation of the pi bond orbital. Okay, and you will start asking me like, where is the sigma bond? The sigma bond here is in here, and this is pi bond. By the way, one of these is sigma, one of these is pi. But how can I represent it in terms of this drawing? We told you that this is the cloud of the pi, and it contains 1 electron, and this is the other cloud that contains 1 electron. Suppose that you have a carbon atom here, and this is a carbon. It has an orbital that overlap in a form of sideways. We have another orbitals that interact with each other in a form of end-on, which is in here. Okay, so this is sigma bond in this case, and this is pi bond. So if I ask you to draw the pi bond orbital, you have to show me a cloud above the level and a cloud below the level. Which level that you talk about? So suppose that we have this here, we have sigma bond, and my question is, how can I draw the pi bond in this case? Or let's say draw the pi bond orbital in here. All what you have is drawing a cloud above the sigma bond and another cloud below the sigma bond. So this is the best way of representing the pi bond orbitals. This is very nice and good. The question now, how can I determine the number of pi bond and sigma bonds if you were given an organic compound? So let's take this as an example. So first of all, you have to look at how many pi bond we have. As we can see here, you have 2 double bond, which means that you will have a pi bond in here and you have another pi bond in here. So far, we have 2 pi bond. Good. But now if I want to determine the number of sigma bonds, I want to clear all of these issues. Okay, and I want to start explaining and write it in details. Since the skeletal formula doesn't show you the bonds between carbon and hydrogen, you have to put these in your mind. So according to what we have here, you have a carbon. This carbon makes 2 bonds. Then we have 2 CH bonds in this carbon. And the same thing here, we have 2 CHs, 2 CHs. The carbon here makes 3 bonds. Then we have 1. We don't have a CH bond since the carbon makes 4 bonds. The same thing is repeated here. We have CH, CH. The same thing here. And here we don't have any bond in the C double bond because it makes 4 bonds. This carbon here makes 3 bonds, which means that we have another CH. You have a methyl group and we have another CHs in this case. This nitrogen here is all about, I just want to clear it and just show you in way better. Okay, so far we have CH bonds a lot. Let's use a color, okay, and let's start counting these. Since you have double bond in here, it indicates that you have a sigma bond and pi bond. Put this in your considerations. So let's start. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so far we have 2 pi bond and 32 sigma bonds.